Problem number 1019, next greater node in linked list. You are given the head of a linked list with n nodes. For each node in the list, find the value of the next greater node. That is, for each node, find the value of the first node that is next to it and has a strictly larger value than it. Return an integer array answer where answer I is the value of the next greater node of the ith node. Okay, one indexed it. If the ith node does not have a greater node, set answer I to 0. Okay, so first of all, I would like to know the range of n, and the value of each node. The range of each node value. Yeah. Okay, so n is in all positive integers, and there for values there is no. It is at least larger than 1. There will not be empty linked list. Okay, so like the brute force approach will be yeah, like the brute force approach will be like standing at this node, then we will try to find the next node that is larger than 2. So we will find next 1 is not larger, and then 5 is, so we will add. We will have answer 0 to 5, and then we will move on to the next node, and we will start finding again, and it will be it is 1, so there is 5 as well, the next node, and we will write down 5 for answer 1. Yeah, and this will be time complexity will be n with the power of 2. Yeah, for this range, I think it will be okay. Yeah, it will be 10 with the power of 8. Yeah. Okay, then maybe let's first do this and let's see if there is any optimization. Yeah, I think optimization will be yeah, because the bottleneck is keep finding the node on the right, and if we first keep track, memorize the node value first, then yeah, we can know the nearest large value at the current location. So yeah, maybe we can loop through and get all the values, and then yeah, we can generate the answer. And yeah, that will be time complexity will be O(n). So yeah, let's have values, and you will have current node equals head, and we'll start traverse the linked list. Now we will append the value of the current node into the array, and then we will move our pointer current to the next node. Then yeah, we have values and I think this is like keeping track of the local large value, local max. So okay, that's how I think we should reverse to find the local large value, because yeah, I would want to start from right and go to left. Yeah, because this is asking for the right if any value is greater in the right. So I think I will do in a reverse way. I will first have max value equals 0 first. It's a default value, and then I will have the return answer that will be dense of value, and with 0 for default. So it will be like this. Okay, we'll have n equals values length, and answer will be also n, and we can do reverse traversing. So I will have for I in range starting from n minus 1 until -1. So Oh, I think so I will first check if max value is larger than current value, that will be values I. Then answer I will be max value. Else, wait, no. I will first have answer I equals the current right max, and then we will update the max value. So max value will be equal to max, its value, and the current value. Okay, so we will return the answer, and okay, we can dry run. Like for example, one we have 2, 1, 5. 2, 1, 5. Yeah, current equals had while current, so while 2 values append current value 2. Current will be current next, will be 1, and then it has exist values append current value, which is 1, and we will move on to 5. And 5, it exists, and it will append 5, and then current will be current next, it's none, so it will stop the for while loop. Then we will have n equals 3, so we will have this 3 spaces, have max value default to 0. Then we will start for looping the values in a reverse way. We'll start from n minus 1, which is 2, which is 5. Okay, 2. For I is 2. So answer 2 will be the default max value, 0. This will be 0. And max value will be comparing with the current value. So vals 2, it's 5. So max value will be updated to 5 because 0 is larger than 5. Then we will have 2, then it's 1. Oh, I forgot the steps. So it's 1, I is 1, and answer I will be 5 now, since it is the local max in the right. And max value will be updated by max 5, and values 1, it's 1, so it will not be updated, that is still 5. Okay, oh, this is 5. Oh, sorry, this is, we'll update it from here, and this is 5. Then it's 0 now for I. Answer 0 is the current max value, which is 5. And max value will not be updated because max value is 5 and values is 2, and 5 is larger than 2, so it's still 5. Then we return the answer 550. Okay, I came up with the linked list solution, like it says return an integer array answer, so it does not tell us to return linked list. So we still need 2 loops. We can reverse the linked list and start it from 5, for example. Then we can maintain the max value. And then maintain the max value and also update the answer. But we also have to it is possible. But let's first see if this solution works. We have to okay, I think we need like if answer if values I is smaller or equal maybe like this, if values I is smaller or equal to max value, the right max value, then we can write, we can have the answer I with max value, but else we will have 0. It means there is no, it is the current maximum, so there is no values in the right is larger than current, than values. And here we will update it. We can try run like maybe 5. And this will be for max values. Let's start again. So we will start it from 3. And answer 3 will be 0 if values 3 is 5, 5 is smaller or equal, no, but it is still 0. Or maybe we can start from, since the rightmost answer will always be 0, we can maybe start from n-2, then let's see. So it's Okay, and minus 2, then it's 2. So answer 2 equals, oh, yeah, then max value should be default to values and minus 1. So it's 5. So if values I, so if 5 is smaller or equal to 5, then have 5, yes. So this will be 5, and it will not be updated. The max value will not be updated. Then it will be I equals 1. So answer 1 will be max value, which is 5. If values I is 1, 1 is smaller or equal to 5, yes. So it will be 5. Yeah, and 2 will be 5 as well. Yeah, this value 2. I'm thinking of another condition, so maybe like this, and 3, and then there will be 7 here. Okay, so this is 6. Values will be 3, and yeah, we will have 6 zeros. Okay, so we'll start from 0, 6, 4. We'll start from 4. Answer 4. Okay, this one. Answer 4 will be max value 3 if values 4 is 5. If 5 is smaller or equal to 3. No, so we'll have 0. Okay, then max value is 3, values I is 5, so we will update 5. Okay, then it's now I equals 3. Answer 3 will be max value, which is 5, if value 5 smaller or equal to 5, yes, so we will have 5. Then we will not update. And for, okay, so now I is 2. Yeah, 2. Answer 2 will be 5 if values I, which is 1, smaller or equal to 5, yes, it will be 5. And it will not update the max value. Okay, and let's move on to 1. I equals 1. So answer 1 will be 5 max value if values I, which is 7, smaller or equal to 5, no, so it will be 0. Max value equals 5 and compare with 7, so it will be updated to 7. Then it's 0 for I. Answer 0 will be 7 if 2 is smaller or equal to 7, yes. So this will be 7. And 2 will not update the max value. So return answer. Okay, let's see. I have checked the solution, and yeah, it's a mistake that I shouldn't use a variable to store the maximum value, since it is finding a local maximum. and the approach I am using is finding a global maximum, so it will not work like this kind of situation that I will fail. So I should use an array to like a monotonic stack to keep track of the local maximum. So let's clear the stubs. Okay, so we will have a stack max, that's called max value, and it's a stack. And so when we have I will add this to our case. So we will start from right to left, and we will check every time if the current value is larger than the last value in the stack. If it is larger, then it means that the value before all the stacks should be cleared, and since they will not be a greater value anymore. So we will okay, so if the current value is I think answer I will be the last value of the array of the stack. Because it will be the largest value. Let me check, like so it will be like we will keep track of the current local max value, and for each iteration, for each value, if it is if the current value is larger or equal to all the values in the stack, and now we will use a while loop, and like this, the last value smaller or equal to values I. Then we will pop the last value in stack. Because all these values will not be greater than, will not have any chance to be answered. To be the greater value of the node value. So we will pop. And then answer I will be max value. If max value has value, else we will have 0, and then we will append this value into the stack. We first have to calculate the answer before pushing the value into stack, is because we cannot count ourselves into the answer. So that's the order.